Math 1, sequences 1.4. So let's deal with some sequences here. So we want to find the next three terms, identify the constant difference, also known as the growth, and write a recursive function and an explicit function. Okay. Remember, the recursive is going to be a sub n equals a sub n minus 1, and then that common difference, or the growth, and a sub 0 equals, we go back to that starting term. Okay. And the explicit we're writing as a sub n equals the starting term plus the growth times n. Okay, so 3, 8, 13, 18, 23. Obviously we can see we are adding 5 each time. That's our common difference. So I would go a sub n equals a sub n minus 1 plus 5. Okay. Then a sub 0, if I'm going backwards, would be negative 2. Because remember, 3 is our first term. So it's like we have to go backwards to 0. So negative 2 plus 5 would give us 3. Okay, our explicit function would be a sub n equals that starting number, negative 2, plus 5. And because we keep adding 5 over and over, we times it by n. So this would be 28, 33, then 38. Alright, now we've got 11, 9, 7, 5, 3. Okay, pretty easy to see that we are subtracting 2 each time. So that would be 1, negative 1, negative 3. Okay, so to go backwards to get our starting number, because 11 was our first, that would have to be 13. So we'd go a sub n equals a sub n minus 1 minus 2. And then a sub 0 equals 13. And our explicit function, a sub n equals negative 2. Oh, that's our growth. Whoops. 13 minus 2 times n, because that's our common difference, so we times it by n. Okay, then number 3. 3, 1.50, negative 1.5, negative 3. Maybe a little tougher, but we're subtracting by 1.5. So this would be negative 4.5, negative 6, negative 7.5, and so on. So my explicit, a sub n equals my start, which we'd have to go backwards. We'd add 1.5 to 3 to get 4.5. 4.5 minus 1.5n. A recursive, a sub n equals a sub n minus 1 minus 1.5. And a sub 0 would equal 4.5. Alright, now let's take a look at this graph. So Olaf is a mountain climber. The graph shows Olaf's location on the mountain beginning at noon. Use the information in the graph to answer the following questions. Okay, so here's our information right here. What was Olaf's elevation at noon? Okay, well, noon's down here, so we find the point right there. Okay, this is 5,000 and 10,000. We've got 1, 2, 3, 4, 5. So we're probably going up by 1,000. Okay, so 5, 6,000, 7,000, 8,000. So it'd be 9,000 feet. What was his elevation at 2 p.m.? 2 p.m.'s right here. Find that point. It's 7,000 feet. How many feet had Olaf descended from noon until 2? Well, started at 9, went down to 7. So, 2,000 feet. Olaf reached the base camp at 4 p.m. What elevation is a base camp? Base camp's here. Pretty obvious, it's 1,000 feet. During which hour was Olaf descending the mountain the fastest? Okay, so now we're looking at how quick we're going down. Okay, so kind of way to do this would be to connect the dots and find which one was the steepest. And I think it's pretty easy to see the steepest because all of these are an hour apart. The steepest is 3 to 4 p.m. So from 3 p.m. to 4 p.m. How do we know? It's the steepest slope. Okay, says, what is the value of f of n, the time, or the elevation? Okay, so n, right, would be our input. When we're talking about this function notation, this is our input. Our input would be the time, making our output f of n would be the elevation. All right, and there we go.